Hi, my name is Romeel Davé, and I was told to make this little video so that I could introduce myself to you and possibly get you interested in some of the work that I do. So, I'm a galaxy formation theorist. I run supercomputer simulations trying to understand the evolution of the universe from the Big Bang until today. And particularly, I'm interested in how galaxies come to be. Galaxies, as you know, are extremely varied in shape and size and color. And yet they all arise from a very smooth initial conditions shortly after the Big Bang. The physical processes involved with this are numerous. They involve not only cosmology, but things like star formation and feedback and dark matter, the nature of dark matter, black holes within galaxies. All these things are put together in a way that we don't really fully understand how it comes about. But one of the things we have learned is that galaxies form within a cosmic ecosystem where gas is flowing in, forming into stars. Those stars release energy, which drive out winds, and some of that winds cycle back into the galaxies. So you have this baryon cycle of material that's going in and out of galaxies all the time. And understanding that baryon cycle, I think, is the key to unlocking galaxy formation. So we've been trying to understand the baryon cycle using a number of different approaches. The majority of our effort goes into running these large supercomputer simulations. We've developed in our group a new suite of simulations called the Mufasa simulations, and it uses state-of-the-art codes. We've updated a lot of the recipes, the physics that goes into these codes, and as a result, we're able to get some of the best matches to observations across cosmic time of any simulations out there. So this provides a great platform to explore a huge number of different extragalactic observations and try to understand what they're telling us about the physics of galaxy formation. So you can see there are many different ways, many different projects that you could potentially do in our group. Whatever you happen to be interested in, whether it's dwarf galaxies or galaxy clusters, whether it's the first galaxies, the epoch of reionization, or the biggest, most massive, oldest galaxies today. Whatever it is, these things are in principle in our simulation, so you should be able to look at that and try to compare to observations and see where our models are failing and succeeding. So, whatever it is you're interested in, as long as it's something to do with extragalactic, black holes, galaxies, intergalactic medium, all of these things are potential projects that we could work together. So, if you're at all interested in any of this, just fire me an email. Maybe we can Skype, maybe we can hang out, whatever it is. And I can give you more information about what sort of projects might be available and see what you might be interested in. The field's really wide open. We're kind of a small group. I have a variety of international collaborators, but I'm not one of these giant projects that where you'll slot in like some cog, right? I try to work very closely with my students, make sure that they're the ones leading the project, they're the ones driving it intellectually. And that's what I try to train you to do as a PhD student. So I think the opportunities are great. If you're interested, just give me a ring.